Hello students, in this I want to discuss a very important topic, that is decoder, and in this I am going to discuss the 2 to 4 decoder. But before that I want you to understand first what is decoder. Decoder is a combinational circuit. That is the first thing you have to remember always. And as you know that every circuit has got input and the output. So decoder is a combinational circuit that has n input lines and maximum of 2 to the power n output lines. Means if there are two input lines, that means output lines will be 2 to the power 2. That is the value of n. So 2 to the power 2 equals to 4. So a decoder with two input lines will have 4 output lines. Similarly, a decoder with 3 input lines will have 2 to the power 3. That means 8 output lines. Alright. One of these outputs will be active or high based on the combination of the input present. Means out of the out of all the outputs, only one will be active at a time. Alright, when the decoder is enabled. That means decoder detects a particular code. This is a very important line. That means decoder detects a particular code. The outputs of the decoder are nothing but the min terms of n input variables or lines when it is enabled. So always remember, whenever you will write the combination of the input variable, that will always be min term. What is the min term? It's a logical product of the given input variables where we complement zeros and ones are not touched. Alright. So we are going to discuss 2 to the power 2 to 4 decoder. Now students, here you can see a block diagram. So you will first draw a box, that is 2 to the 2 to 2 4 2 to 4 decoder, and two input lines you will show, and you will write two input lines, and then there are four output lines. All right, and these output lines, suppose you are having this A and B, so here you can have outputs as Q0, Q1, Q2, Q3. Or if you are thinking and you know it very well that these are going to be the decimal numbers, so you can write as D0, D1, D2 and D3. So it's your choice. Alright, so it's a simple block diagram. So the definition, after definition you can draw a block diagram. So this process can be explained in terms of the truth table also. So here you can see that the input combinations are there: 0 0, 0 1, 1 0 and 1 1, and all the outputs like Q0, Q1, Q2, Q3. Alright, and only one will be active at a time. So when the combination is 0 0, so it's a binary combination, it produces which decimal number? 0. So here Q0 will be having 1 because that is active right now. Then 0 1, 0 1 represents what? It represents decimal number 1. So Q1 will have 1 in this row and rest of the columns will have 0. Alright, and then combination is 1 0. Then here you can see that 1 0 produces which decimal number? 2. So Q2 is having 1 and rest of the columns are having 0. And then the last one is 1 1, that represents decimal number 3. So Q3, students, it will have the value 1, rest will be of 0 0 0. So with the combination 0 0, Q0 is having 1. With the combination 0 1, Q1 is having 1. With the combination 1 0, Q2 is having 1. And with the combination 1 1, Q3 is having 1. And all the others will be having the value 0. So students, that was the block diagram. This is the truth table. Now this entire thing can be implemented in the form of a circuit. So definitely we have got two inputs here. So signal 1, signal 0 you may have, or you can have them as A and B. It's your choice. And these outputs you can have Q0, Q1, Q2 and Q3, or you can have F0, F1, F2, F3, or you can have D0, D1, D2, D3. So it's your choice. But what you need to do is whatever the variable you specify, that must be there in the truth table, if you have the truth table to support your answer. All right, now students, here you see, when I look at this, so you can see that two lines have been drawn. One is for A and the other is for B. You will draw two lines, and after that there is a NOT gate and there is another line drawn for this. So that means when the A is 0 or A complement, and here B 0 or B is complemented. All right, so every input is having its complement also. If this is 1, so this is 0. So when we want to produce F0, that means I have to connect this input line, that is this one. This is A is 0, so A complement, and B is 0, that means B complement. So that will be connected, right? And after that, when I have to produce F1, so combination is 0 1, so it will be A complement, that is 0, A is 0, and then B. So B will be connected, and then this output is drawn. When I have to produce F2, that means 1 0, that means A B complement. So this is A, and then NOT B will be connected, that it will be the B complement with this, and output is F2. Now the combination is, here you can see that A and B. So when these both are there, then F3 will be produced. All right, so it's quite easy. I hope everybody has understood it well. So here notice, when input is 0 0, F0 produces one output, 0 1, that means F1 produces one output. When 1 0, F2 produces one output. When 1 1, F3 produces the output 1. Whenever there is a 0 in the input, line is connected to the inverted input. All right, for every 1, the input line is connected to uncomplemented input. All right, and here F0 equals to 0 0, both are 0, then both the inputs are connected to inverted signals S1 and S0, that is A dash and B dash, or A complement and B complement, or A bar or B bar. Now students, here you can see F1 0 1, or you may call it S1 here, that is A0, and S0, that is B equal to 1. So it will be what? It will be F1 is connected to A dash or A bar and B. Similarly, F2, which is 1 0, right? So in this case, F2 is connected to A and B bar, and F3 1 1 is connected to A and B. So I hope everybody has understood it well. Thanks everyone.